also that you should take note of on the PLC panel, you will discover that I discovered that my PLC, sometimes looking at my PLC, trips off, and I discover that this is actually the scapegoat. If you look at my hand, one of the wire, which is actually for the positive 24 volt, is controlled by a branch circuit breaker and is actually flickering, shaking. Okay, so for today we are starting with understanding LED indicators on the PLC. The same way you understand whenever the fuel gauge of your car is low, the same way you understand when your phone battery is low, when there's no internet connection, you should be able to understand the diagnostic LEDs for the PLC and even for your input and output section. So for today, let's focus on the input section. If you look at the input, and if I should actually click on the few devices starting from the green push button, okay, that it's actually here. If you look at it carefully, alongside this, you discover that the green push button is responding. So I tell people things like wire break, things like feedback signals are things that you should be able to confirm that the hardware is actually in good condition. So if you look at the green push button is closed, the next green is closed, the red is defaultly closed, okay? And when it is pressed, it is actually open. Then we have a two-way selector switch, which means closed towards the left. The middle position is actually the off position. Then to the right, closed also. If you can see the indications here all blinking, then we have the emergency, the green and the red, and another selector switch. So take note of diagnostic LEDs, okay, and even indicators for your input section. They can tell you what's actually going on the field. For instance, if you look at this sensor on my hand, it's actually a capacitive sensor. So if I'm blocking it, you can see an indication also on the sensor to my far right. Okay, you will see an indication there whenever it is actually blocked. You notice it is actually blinking. Okay, so things like, oh, the sensor is not responding, we're not getting a feedback. You know, these are things that you should be able to check for the hardware integrity before you then confirm, or before you then just throw out your laptop and your PG and then worry yourself on things that are very little like that. And if you look at these inductive sensors also, you look at it, obviously inductive won't react to my hand, I'm not fully metal, but watch to the panel and you get an indication right there. So these are stuff that even if you are new in the PLC system or you are new to the PLC panel, you should be able to debug. You should be able to find out what's actually going on and ask, oh, are we getting an indication? Is something actually popping up over there, okay, on the input module, on the PLC and stuff like that. But look at something very important also that you should take note of on the PLC panel. You will discover that I discovered that my PLC, sometimes looking at my PLC, trips off, and I discover that this is actually the scapegoat. If you look at my hand, one of the wire, which is actually for the positive 24 volt, is controlled by a branch circuit breaker and is actually flickering, shaking, and you discover that the indicators are just, you know. So doing continuity test, which is where I'm going to, very important, and why you shouldn't do continuity test for the breakers, instead you do for your wires. Okay, so let's power down, very, very important, and we can just make this simulation very, very, very factual. So let's pull this down, like it's actually shaking and it's flickering and the likes, and you're not just aware, which it could actually cause you a trip in the plant floor. So watch. Okay, so let's power down and then do a continuity test. First of all, obviously, let's return this meter back to the off position. Okay, then watch your meter and you want to take it to the continuity position while you ensure your wires are plugged. Okay, please don't do continuity on a live panel, please. Okay, and you should also do your research on TDRs. I think I'll talk about that because Also with TDRs, though TDRs may be an overkill for sensors as little as 24 volts, but it can be used. But take note of what I've just said now. Don't do continuity on the live panel. Very, very important. So check for your continuity. You must get that beep. Very, very important. Okay. And when you're doing continuity, always go from the very far end to the other end like this. Okay, but if you notice, the breaker is actually off. So if I should put on the breaker and to complete the circuit, and I then do my continuity test, like from the lower point, which is the plus 24 volts, to the L plus on the PLC, you will discover that nothing is flowing. Okay, but if you're actually using your breaker, look at that, you're getting continuity. Don't do this. Test the wires. Don't use this. All right, use your wires. Go from the lower end to the upper end. That's what I call the downstream to the upstream. Okay, so you don't do this, all right, and do this and do this. Oh, it's working or something. Always go from the other end to the lower end when doing your continuity test. So we actually know what has caused that, and I'm actually going to be ensuring that it's well tightened. Now it's well tightened. So let me get my screwdriver, and we're just actually going to do this quickly, and we're actually going to tighten this place up. Okay, this was an experience I went through when this panel was moved for a training and everything was actually shaking. So one of the wires pulled out. I think one of these days we'll talk about the pushing and actually the screw type connections and the advantages and the like. So let's just power up back, guys, and watch. Is this guy still coming up? Watch. And what's actually going on? Is this connected correctly? No. All right, that was why I said do your continuity test also even before you power up. It's necessary, guys. Okay, so let's go. It means this guy is not well connected. It's all happening live, okay, and it's not actually just a fluke. It's what you are experiencing, you're seeing for yourself. Left to me, I was expecting this guy to work automatically. So let's see if our continuity test now that we're actually going to carry out now properly is actually going to give us the results that we need. Okay, so let's tighten this. Then I can then do this now. Let's do that continuity test. Remember, from the lower end to the other end. Now you can hear the beep. Even here, the beep is there. To the other end, the beep is there. To the other end, the beep is there. So check round and ensure your circuit breaker is on. So let's do this again. Off position, back on to this, converting to 24 volt, back here, live. And you see, your PLC is always talking to you. Tell me what you've learned today, and also tell me if a single wire just like this has actually delayed you on the job in the plant. See you next time. You see us.